Good morning, dear students. Welcome to the lecture 1 on Unit 4, which consists of the concepts of programmable logic devices. So, in this lecture, we will be seeing what is PLD, that is programmable logic device, why we require PLDs, and what are the different types of programmable logic devices, and later how we realize digital logic functions using PLDs, and what would be the significance of PLDs. So the unit objectives, first Unit 4 objectives. In this unit we'll be introduced to programmable logic devices. Next we'll be dealing with the realization of the functions using different PLDs such as PROM, PAL, PLA, CPLDs, FPGAs, etc. And finally, we will be implementing digital circuits using PLAs and PALs as well as PROMs. So, as per the syllabus, we'll be realizing the functions using three PLDs, that is PROM, PAL, and PLAs. And we'll be studying some of the basic architectures of CPLD and FPGAs. And the outcome of this lecture would be, once you complete listening to this lecture, you will be able to explain functions of PROMs, PLAs, and PALs, that is combination PLDs. So, in this lecture, we will be discussing only combination PLDs, that is PROM, PLA, and PALs. So first, you need to know what is PLD. Actually, you will be seeing lot many ICs, which internally consists of logic gates and flip-flops, and which are designed to perform different logic functions. So we can say an IC is also sometimes referred as a programmable logic device because it internally consists of logic gates. And what actually the programmable logic device internally has means AND gates and OR gates with their connections. Right? So in the first level you will be having AND gates, and in the second level you will be having OR gates. And the main important aspect of PLDs are regarding their connections. So the connections can be removed according to the requirement to AND gates as well as OR gates. And the connections can be placed according to the requirement. That means here the connections are not fixed. The connections are programmable. Means they can be varied. You can remove the connection or you can add a connection based on the requirement. So meanwhile, till now you just remember PLD internally consists of AND gates and OR gates. So in the first level it consists of AND gates, in the second level it consists of OR gates. And their connections, it is very important. The connections would be either fixed or would be programmable. Programmable means you can remove the connections or you can introduce a connection. So it is like switch, right? So whenever you close the switch, the connection would be assumed as it is connected, and whenever you open the switch, it is considered as you have removed the connection. So this is what the concept of PLD. So PLDs, which are nothing but an IC to realize a digital function, and which internally consists of AND gates and OR gates. So in the first level AND gates and in the second level OR gates. And their connections would be fixed or programmable. Programmable means you can remove the connections by opening the switch, or you can place a connection by closing the switch. So how we are realizing this switch in PLDs we'll be seeing in the next slide. So this is what, if I ask you what would be the internal blocks of PLDs? Simple. It consists of array of AND gates followed by array of OR gates. So the number would be decided according to the logic function. Simple, right? So in the first level AND gates, and in the second level OR gates, right? And we will be seeing the different colors of connections here, right? Black, blue, and then black. So we'll be discussing what is the significance of color, how do we indicate the color. Black color means what it represents, and the blue color means how does it would be assumed as. And if there is a line here, it means a group of inputs, not a single input, right? So if there is a line on the arrow mark, it would be considered as you may have any number of inputs, that means more than one input. So don't assume that if it is a single arrow, it is a single connection. So this represents multiple inputs as well as multiple outputs or multiple lines. What are the fundamental PLDs? That means basic PLDs. Three types of PLDs. Programmable read-only memory, that is PROM. Programmable array logic, acronym is PAL, and a programmable logic array, acronym is PLA. So you have to remember these names, right? And don't get confused with the PAL and PLA. PAL means programmable array logic, programmable logic array means PLA. So its internal architecture should be different, right? So don't get confused. And then what are the complex PLDs? Fundamental PLDs are PROM, PAL and PLA. What are the complex PLDs? Means simple. Complex PLDs are used to realize the complex functions. Right? What are those two? Means one is CPLD, complex programmable logic device, and the second one is field programmable gate array, that is FPGA. These complex PLDs may have many gates because these are intended to realize complex logic functions, right? And in nowadays most of the industries would be using FPGA architectures, field programmable gate array. That means it would be having millions of gates, right? Complexity, that means you can realize complex functions. So complex PLDs means there are two types, CPLD and FPGA. So before going to the PROM, right, I want to inform you that what is the need of PLDs. So it has some array of AND gates and array of OR gates, but what is its need? Means simple, which is used to implement Boolean functions in the sum of minterms or sum of products. Right? So any function can be realized using sum of products. So to realize a product term, you require first AND gate, and to sum up all the product terms, you require OR gate. So it's very simple. So if you have an array of AND gates and array of OR gates, you can realize any sort of functions, because the digital functions will be relying on three operations, that is AND operation, OR operation and negation, that is complement. So dot operation can be performed using AND gate and sum operation can be performed using OR gate. So first, to get the product term, we'll be giving the literals to AND gates. Once you get the product term, to add the product terms will be using OR gates. So simple. Right, so this is the need of any PLDs to realize a digital function. Right? And how do we implement a complement? Using NOT gates. So first we'll be discussing what is PROM, Programmable Read-Only Memory. So it is one of the combinational PLDs or fundamental PLD which has fixed AND array gates and the programmable connections for OR gates. It's very simple, right? Which has fixed AND gate connections and programmable OR gates. So this will be discussing later. So what is a programmable? As already I informed you, what is a programmable? It is nothing but you can remove the connections or place a connection according to the requirement. So simple, and it is used to implement any Boolean function which is in the form of sum of min terms. So what is a min term? It is a product term which consists of all the literals. So min term is different and normal product term is different. Min term consists of all the literals in this in the term. Right. Next, PAL, Programmable Array Logic. It has programmable AND connections and a fixed OR connection. So this slight change to that of PROM. What is a PROM? Just now we have discussed. What PROM consists of fixed AND gates and programmable OR gate connections, whereas PAL consists of programmable AND gates and fixed OR gates. That's it. So just reverse to that of PROM is nothing but a PAL. So sometimes you may require to remove the connections to OR gates. So there are some applications. We will be discussing it through an example. So as I said, coming to the next point, as I said, programmable connections are done using fuses, which acts as a switch. That means you can remove the connection if it is not needed using the fuse, or you can enable the connection if it is needed. So this is very flexible, right? So the number of connections can be removed which are in not use. That's very simple. Right? Next, PLA, Programmable Logic Array. In this, both AND gates and OR gate connections are programmable, whereas PAL or PROMs, any one of those AND and OR gate connections are programmable, remaining are fixed. But whereas PLA, Programmable Logic Array, in which both the connections, that is AND gate and OR gate connections, are programmable. So it is most flexible type of PLDs. Why it is the most flexible? Because if the connections are not required, you can disable using the fuses. If the connections are needed, you can enable. So you can realize more number of functions using PLDs. Right? So why it is most flexible? Because all the connections are programmable. So you can repeatedly use this to realize many digital functions. Now you will be getting clear idea what are the differences between three combination PLDs, that is PROM, PAL and the PLA. First one, if you see the PROM, fixed AND array, that means fixed connections. These connections are fixed. Whereas programmable OR gates, that means the connections to OR gates are programmable. So programmable connections are indicated with blue line. Initially I told that what would be the difference between this black and blue line. Blue line represents programmable connections, black represents fixed connections.